You're welcome back to this channel. In this video, I'm going to solve this problem under Fourier series. Okay, the question says that we should determine the Fourier series for the function that is defined by f of x equal to -2 over the interval negative pi less than x less than minus pi over 2, f of x equal to 2 over the range minus pi over 2 less than x less than pi over 2, and f of x equal to -2 in this interval, pi over 2 less than x less than pi. And the function has a period of 2 pi. Okay, so let us start. The first thing we're going to do is to graph the function. Okay, it's a non-sinusoidal function. Let's graph it. All right. This is 0. Let's say we have pi over 2 here. Okay, this is pi. All right. And this side we have minus pi over 2. And we have minus pi here. This is our x-axis. And this is our y-axis. The y-axis corresponds to f of x. Okay. So we are having -2, 2, and -2. Okay. This is -2. All right, the negative y-axis, and let's say this is 2, the positive y-axis. All right, we are assuming that the distance from here to here is the same as from here to here. Okay, it's just a rough sketch, not a perfect graph. So between minus pi to minus pi over 2, minus pi over 2, f of x is what? -2. So this is where -2 is. So from here to here, it is -2. All right. So we can trace it down. Okay. Then between minus pi over 2 to pi over 2, this is minus pi over 2. This is pi over 2. What is f of x? F of x is equal to 2. So this is where 2 is. So let's trace it down. Let's mark it. Let's say from here down to this point. It is 2. Okay. This is 2. So we can trace it down. And between pi over 2 to pi, it is what? -2. So this is pi over 2. This is pi. It is -2. This is where -2 is. This is -2. So we can say from here to here, that's -2. Okay, from here to here. Okay. So -2 is here. Pi over 2. And then we have pi. Good. This is the graph. A rough sketch anyway. So this graph, the function is actually an even function. Looking at it, it's an even function. Remember what we said in the last video about even functions. Even functions are symmetrical about the y-axis. That is, if I fold the graph into 2, it will perfectly overlap. Look at this very well. What is at this left-hand side? The size is what is here. That's if it's a perfect graph. Okay. So the size of what is at the left-hand side is what is at the right-hand side. So I can easily fold it up. It will cover perfectly. That means the function is even. And remember what we said about even functions. For even functions, we only need the Fourier coefficients a0 and a sub n. For even functions, b sub n is equal to what? 0. Remember that for the range minus pi less than x less than pi, a0 is 1 over pi times the integral from minus pi to pi of f of x dx. Also, a sub n is 1 over pi times the integral from negative pi to pi of f of x cos nx dx. But the thing is, we can actually save ourselves the stress of integrating from minus pi to pi. since the function is even. So since this function is even, we can actually take the integral from 0 to pi and then multiply it by 2, something like that. You get it? So the area of this right hand side is the same as the area of this left hand side because the two sides are equal. So why don't we just integrate from 0 to pi then multiply it by 2? So something like this. Over the range now, we can say a naught is equal to, this is 1 over pi. If we are integrating from 0 to pi, we multiply this by what? 2 of f of x dx. And this is what? 2 over pi times the integral from 0 to pi f of x dx. So this is what we will use to determine a naught. Alright? Also, a sub n, the same thing will happen. A sub n will be 2 over pi times the integral from 0 to pi of f of x cos nx dx. So this is what we will use for a naught, and this is what we use for what? A sub n. Okay, so let's go ahead now. Remember to subscribe, like, and share the video to your friends and to your classmates. At the end of the day, we are going to deduce a series for pi over 4, given that f of 0 is equal to 2. So let us determine the Fourier series, first of all, of this function. A naught is equal to, we just said 2 over pi times the integral from 0 to pi of f of x dx. So what's A naught now? This is 2 over pi. Since the integral is from 0 to pi, that is from 0 to pi. So we can take from 0 to pi over 2 first, then we'll not take from pi over 2 to pi. In as much as it is still from 0 to pi, it's still complete. So from 0 to pi over 2 and from pi over 2 to pi. So A naught is equal to the integral from 0 to pi over 2 of f of x dx plus the integral from pi over 2 to pi now. Pi over 2 to pi of f of x dx. Okay, so what's A naught? 2 over pi into the integral from 0 to pi over 2. Okay, between 0 and pi over 2, what is y, which is f of x? What is f of x? Between 0 and pi over 2. F of x is 2. Check it. This is it. It's 2. It flows. Alright, so between 0 and pi over 2, we have y or f of x equal to 2. So the function here is 2. Pi over 2. The function is 2 dx. Okay, plus from pi over 2 now to pi. What is f of x? Pi over 2 to pi. What is f of x? We can see it. It is minus 2. So between pi over 2 to pi, f of x is minus 2. This is the minus 2. It flows. So f of x is minus 2 dx. So we have 2 over pi into the integral of 2 dx is 2x. Okay, we are integrating from 0 to pi over 2. This minus can come out. The integral of 2 dx is still 2x. But the integration is from what? Pi over 2 to pi. Pi over 2. Pi over 2 to pi. So this is it. 2 over pi into, let's plug in the limit now. Pi over 2 will enter for x first. So we'll be having 2 times pi over 2. That's 2 pi over 2 minus 0 will enter. 2 times 0 is 0. Then minus pi will enter. That's 2 pi minus pi over 2 will now enter. That will be 2 times pi over 2, which is 2 pi over 2. Okay, so this is it. 2 over pi into 2 take away 2. We have pi minus 0, which is pi, minus, this is the minus. 2 we take away 2. Okay, So we have 2 pi minus pi. 2 pi minus pi, which is pi. So we have minus pi. Pi minus pi is 0. So everything here reduces to what? 0. So A naught is equal to 0. Let's write it somewhere. A naught is 0. A naught equal to 0. So we said that A sub n is 2 over pi. That's the integral from 0 to pi of f of x cos nx dx. So since we are taking the integral from 0 to pi, it is the same thing as saying 2 over pi into, I'm bringing 2 over pi out. We can take the integral from 0 to pi over 2 first. From 0 to pi over 2 first of f of x cos nx dx. Plus, we now take the integral from pi over 2 to pi. Pi over 2 to pi f of x cos nx dx. Good. So this is it. So we have 2 over pi into the integral from 0 to pi over 2. Between 0 and pi over 2, that's from 0 to pi over 2, we said that f of x is 2. Yes. So f of x equal to 2. So we have 2 cos nx dx. Okay. Plus between pi over 2 and pi over 2 and pi, f of x is minus 2. So that minus can actually come out. Yes, minus. We're having the integral from pi over 2 to pi of 2. Remember, we said it's minus 2, but the minus is outside. Cos nx dx. Okay, since 2 is a constant, okay, 2 is a constant, so I can bring it out. If I bring 2 out, to multiply this 2, here becomes 4. So it is now 4 over pi. Then we will now take the integral from 0 to pi over 2 of cos nx dx, and from pi over 2 to pi of cos nx dx. You get it? So this is it now. Integrate cos nx dx. We are going to have sine nx all over n. So the integration is from 0 to pi over 2. Minus the same thing here, integrate cos nx dx is still sine nx over n, but it is now from pi over 2 to pi. We can see 1 over n here, and we can see 1 over n here. So we can bring it out, okay? So we'll be having 4 over n pi, right? The n is out now. Then, so we can now plug in the upper and lower limit. Plug in pi over 2 for x first, okay? So we now have sine n pi over 2, n pi over 2, then minus. Remember that this n is outside already. This one is also outside, okay? Plug in 0 now for x. We'll be having sine n times 0, which is sine 0. And sine 0 is 0. Minus 0. Minus. Plug in pi. That will be sine n pi. Remember that this n is outside. Then minus. Let's plug in pi over 2 now. That will be, okay, let me plug this in a bigger bracket. Pi over 2 enters, we have sine n pi over 2. Sine n pi over 2. Alright, so what do we have now? This is equal to 4 over n pi into, okay, this 0 is out. Alright, sine n pi is always 0. So this one is 0. So what we are having now is sine n pi over 2 minus minus is a plus. Plus what? Sine n pi over 2. N pi over 2. Okay? The two of them are the same. So if we add them up, we are going to obtain 2 sine n pi over 2. All right. So if we multiply 4 over n pi by 2 sine n pi over 2, we are going to obtain 8 over n pi. You get the point now? This is 2 sine n pi over 2. 2 times 4 is 8. The n pi is still there. Then we have sine n pi over 2. N pi over 2. So a sub n is equal to 8 over n pi sine n pi over 2. So let us determine the behavior of a sub n at different values of n. N equal to 1, 2, 3, 4, 5, 6, 7, and so on. Now this is it. For values of n equal to 1, 5, 9, add 4, that's 13, and so on. Sine n pi over 2, sine n pi over 2 is always equal to 1. For example, plug in 1 here. That will be 1 times pi over 2, which is pi over 2. Pi is 180 degrees. So 180 divided by 2 is 90. Sine 90 is equal to 1. So if you plug in 5, 9, 13 into this, the sine of that value is equal to 1. Since for n equal to 1, 5, 9, 13 and so on, this particular expression here is equal to 1. That means a sub n is equal to 8 over n pi for values of n equal to 1, 5, 9, 13 and so on. So 1 times 8 over n pi is still 8 over n pi. Alright? So for n equal to 2, 4, 6, 8 and so on and so forth. In fact, all even numbers, for n equal to even numbers, this particular sign here will give us 0. Check it out. For n equal to 2, put 2 here. That's 2 times pi over 2, which is equal to pi. Because 2 will cancel 2. So we have pi left. Sine pi, which is sine 180 degrees, is equal to 0. So that is it. So for n equal to 2, 4, 6, 8, this would be 0. That means a sub n will be 0. That is the point. 0 times what is here will still be 0. So for n equal to this, a sub n will be what? 0. What if for n equal to, we have 3, 7, 11, alright, and so on and so forth. Here we took 1, 5, 9, 13, 2, 4, 6, 8. So we are taking 3, 7, 11. The next one should be what? 11 plus 4, which is 15. You get it? So what will be a sub n? Check it out. Let's place 3 here. 3 here. For example, that's 3 times pi over 2. 3 times 180 degrees all over 2. 180 over 2 is 90. So 3 times 90 is 270. So sine 270 degrees is minus 1. So for values of 3, 7, 11 and so on and so forth, the sine is equal to minus 1. So it means that sine n pi over 2 is equal to minus 1. That means a sub n for these values of n will be equal to minus 8 over n pi. That's what it means. Okay, so let's take note of this. Let's keep this aside. Let's now determine the Fourier series. Okay, so I think I can erase this now. So what will be f of x? A naught over 2 plus the summation from n equal to 1 to infinity, okay, of a sub n cos nx. There is no b sub n, there is no sine nx. So what is a naught here? A naught is 0, that's what we got. So 0 over 2 is 0, that one is out. So we are not taking the summation from n equal to 1 to infinity of a sub n cos nx. Okay, so what is f of x equal to now? Let's take the summation. When n is equal to 1, what is a sub n? Remember, for n equal to 1, this is what a sub n is. So it's just for us to plug in 1 here. So we have 8 over pi. Alright, so 1 times pi is pi. So 8 over pi 8 over pi cos 1x, which is cos s. Summation is plus. What if when n equal to 2? Remember, a sub n will be 0. So that one is out. In fact, for 2, 4, 6, 8, and so on is out. Then for n equal to 3, this is what a sub n is. It's just for us to plug in 3 here. So we're having minus 8 over 3 pi plus minus 8 over 3 pi, then cos n is 3x. Okay? When n is equal to 4, we'll still have 0. Okay? So let's go to 5 now. For 5, this is it, a sub n. So we have 8 over 5 pi, 8 over 5 pi cos 5x. N is 5. So for 7, we are going to make use of this. That will be plus minus 8 over 7 pi. We are putting 7 here now. Cos 7x. And so on and so forth. The series is infinite. Yes, an infinite trigonometrical series. So, I don't think we need this diagram anymore. Let's simplify in one step. This is it. We have f of x equal to 8 over pi is common to all terms. It is obvious. So if 8 over pi comes out, okay, we'll be having cos s left, cos s, then minus 1 over 3 cos 3x, minus 1 over 3 cos 3x. Then here we'll be having what? Plus 8 over 5, sorry, plus 1 over 5, 8 is out. Yeah, plus 1 over 5 cos 5x, plus 1 over 5 cos 5x. Okay, let's add the last one to it. Minus 1 over 7 cos 7x. So this plus will become a minus. And so on and so forth. So this is actually the Fourier series for that function that we were given initially that I just erased. Okay, this is the Fourier series of that even function. Now let's finish the job. We are told to deduce a series for pi over 4, given that f of 0 is equal to 2. How do we do this? Just watch and see how it's going to be done. Okay? Now, this is what f of x is. F of 0 equal to 2, it means that x is equal to 0 and f of x is equal to what? 2. That is, when x is equal to 0, f of x is equal to 2. That's what it means. So what we are going to do simply is, in place of f of x here, we write 2. And in place of x here, we are going to put what? 0. And then possibly we are going to see here's pi over 4 will come out. We said pi over 4. So let's go. 2 is equal to 8 over pi. That's cos 0. That's put 0 here because x is 0. Minus 1 over 3. In fact, we'll be having cos 0 all through. Plus 1 over 5 cos 0. And minus 1 over 7 cos 0. And so on and so forth. Cos 0 is equal to 1. Yes, that's it. So we have 2 equal to 8 over pi into 1 minus, if all of them here, cos 0, cos 0, cos 0 equal to 1. It means that we just have 1 over 3 plus 1 over 5 minus 1 over 7 and so on. So we have to deduce a series for what? For pi over 4. So let us cross multiply. I want to remove this 8 over pi from here by multiplying both sides by pi over 8. If I multiply 8 over pi by pi over 8, it will cancel out, giving me 1. So multiply this by pi over 8. 2 times pi over 8 equal to, multiply this side by pi over 8 now, as pi over 8 times 8 over pi into 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 and so on. This will cancel out to give me 1. 2 here is 1, 2 here is what? 4. So we're having pi over 4 equal to everything in this bracket. 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 till infinity. So this actually is a series for pi over 4. Isn't it interesting? This is the series for pi over 4. And this is the Fourier series of the function. So given that f of x is equal to 2 when x is equal to 0, the series for pi over 4 is what we can see on this board. So this is how to determine the Fourier series of an even function. Alright, I hope you enjoyed the video. Keep supporting by subscribing to this channel, like and share the videos to your friends and to your classmates. I am the complex analyzer, and I'll see you in the next video.